Detecting something that small at 70 miles an hour is probably a little hard for most of us, but those models are trained to do that. The idea of repairing something becomes an interaction with a foundational model, but it's still on the edge. There's a maturity curve here. You can do the most great things in the world, but if you don't have a data pipeline, you don't have governance structure, you don't have the skill set, you can proof of concept it over and over again, but you don't have a plan to scale. Like previous methods, maybe you set it and forget about it. Not with AI. It's like you're going to parent this for the next few years, if not 10 years. Thank you for the invitation. I have the pleasure of being the Chief Business Officer at SEMA AI. Prior to this, I was leading globally over 20 AI services at AWS and also led some of the early works for Gen AI. My career behind AWS included managing director at Accenture, leading a lot of the growth around Industry X. The early days of tech in business are some of the plays that I had in my career.
I'm noticing on your background, like the SEMA AI, like one platform for AI being promoted there. Can you explain to me what you mean by one platform?
Absolutely. So if you think about what AI has been for the last 10 years, it's been largely driving an experience that's cloud-based or at best a mobile device. But as we start looking at the new and the next generation of AML, including generative AI, brand new infrastructure is coming into play. And that infrastructure is at the edge. The one platform is to give customers one place to turn so they can start investing and scaling that infrastructure responsibly. That includes the silicon to run a complete AI application at the edge, but it also includes the software necessary to make sure that deployment is easy to do, but also reliable and something they can maintain over time. So it's the one platform to choose from to scale AI at the edge.
How would you describe the customer base for SEMA AI? Who do you sell to?
Really, there's three types. There's the customers who have already had at least 3 years of AI experience, and not just in the cloud, but they've also deployed at least a couple of applications on the edge. Those customers are customers that we can work directly with because they have the business case, they have an early stage infrastructure, and they have the people skills in order to take on the complete silicon to software toolkit in order to build and scale their AI applications. So that's about 1/3 of our customers. The other part is partners. These are your system integrators, your ISVs, who are beginning to absorb more of the AI application, not just from cloud, but now they're looking into meeting demand signals from the edge. So they again have the toolkit, they have the infrastructure, and they have the skill set. And last but not least, we're also working with the ODMs and OEMs. These are customers or partners that are looking to embed AI into their hardware or product. And these tend to be long design cycles. These players tend to be earlier in their AI journey. And with them, we do provide the same tool chain, but we also provide a lot more support.
So is that integrating LLMs into hardware? I noticed that on the website, it's like automotive, healthcare. So it's not just like calling the OpenAI API, it's natively integrated.
Exactly. So the one thing with Edge AI is you're running the inference on the device. Whether that device is a mobility device, a forklift, or an industrial PC on your manufacturing line, or a smart camera in your retail store, or maybe a campus where you're looking for some type of analytics. That whole inference is happening on that device versus having to go back to the cloud to run that inference.
Could you explain to the listener like what an inference is? I'm going to use
Sure.
a real example I just saw. There's this port in China that had completely autonomous freight trucks. A lot of the employees controlling, well, it wasn't completely autonomous. There was remotes, employees in an office building controlling a lot of like the cranes and everything like that. But there was no like longshoremen, like dock workers, like doing a lot of the work. And it was timely because of these strikes that happened recently in the US, like the port strikes. One of the things that they talked about was in their like negotiations was that they wouldn't automate things, protect jobs. Now, I'm taking a bit of a leap here, but in your explanation of an inference, like what does that mean in the context of like AI and technology from an application perspective? And then potentially what does that mean with hardware, like in vehicles when you implement
Sure.
something like that?
Sure. Absolutely. So maybe we'll take a step-by-step approach. So an inference at the end of the day is a prediction. For example, in manufacturing, you have lines that can move up speeds of greater than 70 miles an hour. And you're looking for defect size of a piece of black peppercorn. We're helping customers train models that can see, detect, and classify that fast. We're making a prediction in real time on the edge compute to be able to say, I detected a defect and this is what it is. So that's what we say, here's your inference. From a user perspective, hey, telling me there's something wrong on my product that's moving that fast isn't enough. This goes back to like, what does the user think? At that point, the customer has rules. What do you want to do when you see something like this? You can say, slow down the line, send a signal like a green, yellow, red light, or send an email. But there's something that takes action based on that prediction. Something's wrong. Here's my business rules. Go tell somebody to go do something. It could, whether that's a person or a machine, i.e. the machine, you can just immediately set it up so that it starts slowing down, so that somebody has time to fix what they have to prevent those defects from happening again. So that's really an application of these models. Detecting something that small at 70 miles an hour is probably a little hard for most of us, but those models are trained to do that. And from a user perspective, it's business rules. What would you like to know? What do you want to do now that you know that this exists?
Yeah, I was told that the best way to handle AI, and I'm assuming there's a non-technical or at least semi-technical user here, because I'm trying to determine what's the difference between this and just machine learning algorithms. Technically, we could do that with a computer science person, like programming the computer to do all these things. But I'm assuming what's powerful about AI is that there's a more non-technical interface that's more human-friendly, where
Yes.
it could ask you what you want to do, and the system will be able to act upon it without being programmed to act upon it. Does that make sense? Like,
So there's a spectrum of AI, and then there's a spectrum of what people want to do with the inference or the prediction.
yeah,
In some of these high-speed lines, you still need a prediction, but the way you take action on that prediction can change with the capabilities around foundation models, where you have that more natural interface with them. So when we step back to other use cases, we're trying to enable customers to say, okay, now step back and say, how do you want to change the discourse, sort of the actions you're taking in your operations based on this new HMI experience that we can present you now with natural language? That starts pointing to SOPs. For example, the idea of repairing something becomes an interaction with a foundational model, but it's still on the edge. Whether it's equipment or a product, you have the person interfacing with a device in a very natural language format. And it's in the back end, you're doing some RAG approaches around what data to pull from an SOP database or an ERP system in order to be, again, layman terms, is you're pulling out an inventory of what parts are available so that you can actually do the action you're trying to solve. But again, it's changing that interface for improving the productivity of the user.
it lowers the cost of production because you don't have to have highly trained, highly technical users.
So usually the way people start, again, this is important, Kenny, because a lot of people think there's only one place to start with AI, and that's not true. There's a maturity curve here. You can do the most great things in the world, but if you don't have a data pipeline, you don't have governance structure, you don't have the skill set, you can proof of concept it over and over again, but you don't have a plan to scale. So usually the business case starts in steps. If you're thinking, I'll choose manufacturing, then I'll go to retail. In manufacturing, your first step is increase my throughput with a higher yield. What does that mean? do more. I build more things faster. And number two, build them with less errors. So at that point, the business case is I can build more with fewer errors. I'm saving money. The next level of maturity is going to be, okay, now that I've done more and with fewer quality issues, what else can I do in terms of improving my utilization rate? Can we make our current labor force more productive with some additional supplemental or augmentation applications? For example, the application around being able to ask questions to a system so that the system can help the user resolve whatever issue may be happening in operations, repair equipment, or fix a product. At that point, you're saying do more with less, and that's your utilization rate. The next level would be broader production-wide capabilities where you can move materials with less labor. For example, moving materials with less labor can mean also safety improvements, but it can also mean throughput improvements. So these are stages, Kata, that most people don't talk about, but that's how customers are doing it. They're taking it in steps because they're learning what is the business case of AI.
Yeah, it's not out of the box yet. We don't have enough precedent to make a decision. I just want to compliment your ability to talk about a very complicated space in a concise way. I'm like, oh yeah, she definitely worked at Amazon for a bit. You're definitely a former Amazon executive. I like the concept of the maturity cycle because I think when AI sounds like a shortcut to a lot of people and a lot of bad applications of AI, they go straight to making shortcuts. Maturity implies that it takes time. You have to make mistakes, internalize lessons. How you describe a mature person, it's a person that life's gotten real to them enough that they've tempered their expectations and belief systems about life. I don't think we've made enough mistakes yet with AI to have that mature perspective. The current maturity is like, okay, what can we do to replace this task? Very basic intern level task. And then, okay, we were able to do that reliably. How do we get to this more nuanced, complicated task? And we're starting to see that the capabilities are going so high. Like, I mean, the recent release of GPT-4 eliminated a lot of Tableau's like business because people don't need Tableau licenses anymore or need to know how to do Python. Like these very high level tasks of formatting data should be done through natural language. But like I saw this one AI thought leader talk about how AI still is not very good at is replacing responsibility.
Yes, that's right. And responsibility is one thing is to help someone do something easier, meaning less time, less effort, but also improve its accuracy of doing something. But it doesn't take responsibility for the decision that was made. And that's where the human element is a big part of this. In our role at SEMA, we have to work with people who have made some mistakes already. It's a different conversation to work with people who haven't tried it before because the expectations are off in terms of what's it going to take to actually put this in production, like where you are going to be held responsible, to use your words, Kaden, you are going to be held responsible for this model's performance. And it's not just about, oh, it was so cool. It got the right answer. It's you're now taking responsibility, just like you take for responsibility, or we take responsibility for people we hire, that they're going to do the right thing. Right. And that's one of the lessons learned is working with people who've already made some mistakes is a little bit more fluid. It's an experience that's very different than working with someone who's never done it before.
And it is familiar with responsibility and the consequences of being held accountable. There's a maturity there that doesn't really come from a lot of typical B2B SaaS use cases. It's kind of hard to apply AI to SaaS, but ironically, historically difficult industries that have been hard to disrupt, like supply chain, produce with what I work on, and manufacturing. These are a couple hundred years since the Industrial Revolution of precedent and multi-generational subject matter knowledge that you can start applying AI to.
Right. It's not the way we're seeing on TV yet or radio. I think that's one of the things, that I love what you were talking about, and you're bringing it back to responsibility, because it's not responsibility to the people, but and customers or your team, but a responsibility to the business. It has to make sense. But when I think about one customer in particular, when we were working with them through their validation steps of how do you validate performance? This particular customer is in a federally regulated market, and they produce 1 million objects a day in just one place. When we were walking through the validation methods, we realized that the traditional methods that they were using, which is nothing to do with AI, it was a different method. But they're still in the process of trying to change the way they validate systems based on the previous methods. They're still learning how to create methods for testing systems based on AI. And that's where we're trusted partners, right? We don't just say, oh, come back when you're ready. No, we'll work with you to make this journey. And that's, I think, to absorb this responsibly, you have to think through the whole process of how am I going to be responsible and accountable? Not just the consequences, but did you validate the system? In many cases, customers are just beginning to learn how to do that.
Oh my, I mean, new wrinkle in my brain here, because you think about the adoption curve, like the famous bell curve, laggards, early adopters, and it makes you think like, oh, well, what makes someone a late adopter? It's probably the idea that like, I don't trust this thing to advocate responsibility over this task, right? Like, and so I'm not going to adopt it. I might be an actual detractor from this technology even existing in the first place. There's a really great story about how shoes became cheap enough to mass produce. I forgot what the book I read, but it talks about part of the production process for shoes where you attach the sole to the top of the shoe. It was a bottleneck. It was the reason why the production costs were so high, is they needed these specialized craftspeople to attach the sole, and it was very time intensive. And so at that time, like only like middle class, like rich people had shoes because of how long it took. And this guy made a machine that automated that process. The guild or the union of these cobblers were like, this is just a fad. But they're like, I don't trust this machine. I've dedicated my whole career to being paid to be responsible for this. And now that responsibility is going away. And I'm like hearing that, I mean, you're right. Like SAP, Salesforce, like these technologies that in theory could solve a ton of problems, but you need to pay millions of dollars in solution architects and consultants to maybe get the full value out of those expensive software licenses.
Yeah. I'm trying to think about your examples with Salesforce. I think we all know the traditional model has been you pay licenses and then you pay consultants just because you're trying to tune it to your needs, right? Within your context, you're trying to talk about what I call the governor. What's the governor of adoption? Or what's the governor of a particular process? I think that's the magic of what you're talking about. That, to me, that's pivotal because it's really about, I always like when I talk to customers, I assume you have the perfect answer. You have the perfect prediction, you have the perfect answer. What are you going to do with that? That starts thinking like, oh, well, I have to think about my business rules. I have to think of my SOP. I have to think about my people. I have to start thinking about the customer. So all of that other stuff starts coming into the fold. And then after they start thinking about it, they're like, oh, then I start asking the second question. Okay, so a model is probabilistic, not deterministic. What does that mean? Like previous methods, maybe you set it and forget about it. Not with AI. It's like you're going to parent this for the next few years, if not 10 years. So that question becomes around what infrastructure you have in place to continually monitor the performance of your model, retrain it, test it, validate it, and then redeploy the new model. Because that's the only way you're going to can do scale responsibly. Then that's the second pause. You're like, oh, I don't have that. So those are the two areas where I just get ahead of, like, don't get stuck on technical conversation. Get ahead of your success. My customer success is to ask those two questions. Assume you have the perfect answer. Trust me, that's going to be the easy part. The other part is thinking through all the changes you're going to have to work through. That's the part that needs a little bit more thought. And I'm here to help you because I've done it with other customers. Happy to help you through that. The next part is what I'm calling edge ML ops or edge ops. We're going to have to help you get that ready too. Because this model, this application isn't do once and walk away. It's going to be monitored for the rest of its life. Those are the governors.
That sounds like, 10 years. The key word in artificial intelligence is it's an intelligence, meaning that it has to learn and be
Yes.
nurtured. With a lot of solutions architecture, the promise is that you get the business requirements, and if it's a group of solution architects, they can program to meet most of the use cases, maybe 80% of them, and then the rest is like SOPs and policy. And the promise of AI is like automating SOP. And
Yes.
it eventually just gets to a point where it's just policy and put it into a computer, but the time horizons are way longer. When I hear 10 years, most businesses, especially manufacturing businesses, can't do that in-house. I'm starting to see where you're getting at with what SEMA is trying to do. You probably need a strategic partnership to actually pull this off.
That's right, Kaden. This is the ecosystem. When I was asked 3 years ago, what is a real innovation around AI? I said, it's not the technology, of course, but it's going to be doing a rehaul on the ecosystem. The ecosystem, especially on the edge, is just beginning to move from edge compute, call it traditional or legacy edge compute, to how do I incorporate AI that actually takes physical action? One thing is to give a good answer for Salesforce or Tableau. This one is a physical action. A physical action will happen because of this result. And that needs partners. It completes, where customers are today, and software and silicon is here with SEMA. Everything in between is that partner ecosystem. And I'm happy to say that, we're over 20 partners strong. It's taking them with us as we work with these customer engagements so that there is this muscle building around how do you go from just the first generation of the model to the second and the third. And it's going pretty fast.
Man, what an exciting time to be alive. We're going from the old school Silicon Valley software, like relational databases, CRUD databases. A company like Oracle was at the right time to make something that's not very sophisticated by today's standards, like become a very successful business because of just the fact that like we were able to cheaply store data and connect the dots was valuable back then. Now we're getting to a point where we are trying to get software to make like physics decisions. Do we trust it to do a non-chemical changing the state of something? Maybe like, okay, like moving something from point A to point B, like you could reverse that. But then like you're going to start making product decisions about like irreversible decisions where like chemically something's changing into something else. And like that's a roadmap decision 10 years, 20 years from now.
Yes. Yeah. Yes. So I'm going to step away from SEMA and just general thoughts, right?
Yeah.
When I was in my previous role last year, and I could say 99% of my conversations were Gen AI, I started to see how the pharma industry was beginning to rethink of itself in a way that it was all of a sudden the customers were becoming ISVs. I can see it. Like they were beginning to start thinking, if we use AI, we can possibly do discovery different and almost create IP out of prompts, if you will, because that's part of the discovery process.
ISVs, could you just clarify what that?
Independent software vendors. So SaaS people. Yeah. And to your point, it wasn't going to happen overnight is, take whatever I just pulled out of this AI system and go change the formula, if you will. But what was happening is changing the way we discover what else is possible in pharma, in the discovery process of new formulas. That was pretty eye-opening. And I think to your point, will it change overnight? No, there'll be a lot of validation over the next few years, but it's already started.
Well, I am curious with like how a service engagement is with SEMA. This would be perfect double dipping with my day job, like produce space, right? Like the produce has is a fragmented industry. It has three problems going on. Like there's agronomy data, there's supply chain data,
Mhm.
and there's the financial aspect of it. And usually those are separate businesses. And then there's like this level of like trust that has to be built. A lot of schmoozing, golfing, events to develop these like long-term relationships. And the reason they do these long-term partnerships is that the goal is to work with someone over the course of like a decade so that you can
Yeah.
amortize the losses, because about I'd say ineffective, like if there's always going to be loss in produce, but there's the loss happens because the people doing the financing has their own agenda, and the people doing
Mm.
the production have their own agenda, and then the people doing the marketing and distribution have a relationship with Costco's and the Walmarts of the world have their own agenda. And like if it like the goal of like what I'm doing in my current day job, and I won't like really talk too much about like the names and stuff to make this more of a timeless episode, but like we're trying to like marry those things together. Obviously, hard problem to solve, but
Yeah.
like let's say that like I'm engaging with SEMA AI, and I'll use like the example of one of our customers, a marketer, distributor marketer, Central Valley, California, sell grapes, and I'm trying to get 52 weeks supply out of the year. And from like, all over Latin America, and I have to like make a production plan. Like what would that like look like if I wanted to like invest in an AI partnership for
There you
10
go.
years?
Okay. Yeah. Okay. Well, first of all, that's an exciting and a good thing to be working on, by the way.
Yeah.
Just, well, I've done a little bit of ag in my previous role. So the way it for SEMA, first, we wanted to know what have you, obviously you want 52 weeks worth of a level of yield of grapes that you can turn around and give a high level of confidence contract to a distributor, right? So the question that works backwards is, what have you tried to what have you tried in terms of technology in order to reduce the, how could I say, the most variance that you've had with your predictions on your yield, right? Let's just pretend it was, hey, I could have had better yield if I had more data about my soil moisture, or I had better information about how my produce was coming up. Let's just pretend it was a AI problem, like it was said, right? Let's just pretend it was that. For us, we would say, okay, what was the gap? And we would work with you to try to understand where in this process of the application of AI for these, let's call it these two problem areas, did you just not meet requirements with? And we're going to figure out, was it a throughput issue? Was it not the right sensor because you were limited by throughput requirements? And others, i.e., you didn't have the right sensors, or the sensor didn't have enough resolution for your requirements. And then we're going to figure out, who do you work with? And this part is technical. The rest of it starts becoming, who are your partners? Who's in your ecosystem that we can work with? And we will work with your ecosystem. Again, to your point, this is a 10-year relationship. We want to help your ecosystem get to the point where they can solve these problems together with you a little differently with AI. That would be what the most win-win for you. So that way you're not dependent on a vendor. We're simply there for a period of time to help your ecosystem of partners that you trust kind of begin to understand what is possible, and we'll work with you to deliver that. And then we'll stay with you until you reach results. And that comes in the form of, yes, some hardware, and form of our dev boards or our silicon. Yes, on software in the form of software development kits. And yes, a little bit in terms of services over a period of time. But again, the goal is to help your ecosystem get enabled to support you over time. Does that answer your question? That's the most important thing is.
Yeah. Well, yeah, I have a follow-up question. So there's hardware implementations. Is it
Yes.
like, this is my conceptual model, like when I hear this, because it's like, okay, we're basically training like a replacement for an intern or an employee or something like that, like some governor of like a
Yes.
process. And
Mhm.
so you're implying that like, oh, you have to have like on premises hardware to do this, because you're implying that, no, this isn't just like calling an API from like an LLM somewhere. Like you need something like on site. Like you can't depend on Wi-Fi to run a critical business process. And so it's like you're almost like bringing in like an employee, like a physical employee on site. Is that like the right mental model to understand
Well,
this?
I love that those are two things with the governing, two attributes that you just talked about, Kaden. One is I'm going to forego the human part of it for a minute. But the idea that if you're operating in environments where you have to collect information where internet is limited or unreliable or simply not there,
Yeah.
right? And if you want to run more real-time analytics so that you can take more real-time inference and therefore more real-time changes, whatever that change is, right?
Yeah.
And it's not measured in days, but it's measured in minutes, if not seconds. That's when you need that to rethink, okay, where do I push, how far into the field do I push this compute capability so that I can change the profile of how fast I'm learning about what's going on. So yes, you might have like an edge server, or yes, you might include some of these sensors into your equipment that you have in the field, right? Or yes, you might install capabilities in your field in order to collect this data and do more real-time analytics and inference right then and there. But it's definitely pushing how it's like if you go at a spectrum of time and you've been collecting information with a certain velocity and analytics with a certain velocity, all of a sudden you move that over from here, which is days, down to like minutes or seconds. You're gonna have to that's when you start rethinking, where do you put your compute?
Where do you put your compute? Like that's an actual like decision. So let's focus on, agronomy data, like sensors on site. Most farmlands in Latin America, there is zero service. It is in a very remote location. I went to Peru. I went to Peru for work, and you have to fly to like a remote airport, drive for 2 hours, because the conditions there are like perfect year round for like
Oh yeah,
growing things.
yeah,
And yeah, there's nothing there. And I've actually never had that conversation in my career until this job, because it's like probably the second, like this is probably the most operationally intense problem space I've worked on, where a lot of like the software practices it's always like just default is cloud computing. We're going to make queries to a server somewhere in another part of the world, and then compute and then send back a query. I think like for like the listeners, like ask the question, like why are people still using like clipboards and paper forms in a
yeah,
lot of like operational
yeah.
capacities? It's because the compute's not close enough. So like you need a human, like their brain is the compute, and then they have to like go make decisions and then fill out paper form and then go back to somewhere where there's internet and then put it into some database to get their work done eventually. Like the latency of like actually making a enterprise level decision is so long. And so how I mean, I guess I would say like bringing an on-site human with on-prem software, I mean hardware, it sounds more like you need like the brain, like compute, like where do you want the compute is like a really good way to put it, because it's like, okay, if there's no internet, is the technology good enough where is the hardware portable enough and small enough to bring like a decision-making computer on site that doesn't require querying a server somewhere?
That's right. So then it becomes like, how do you power that, right? How do you power that edge compute? In many of these cases where you're just trying to collect it and don't run inference, you may think about if it's battery powered, right? Or like an electric vehicle or something in the form of that factor. This sounds like a little bit like, yes, it's true, but SEMA, one of the things that people like about us, we're high performance. It's 50 tops at 5 watts. That means lots of throughput at very little power, which when you talk about an autonomous device that becomes your edge compute, you can have you just increase your range. Then you can operate doing what you have to do without having to come back and recharge, if you will, or without needing that cord, so to speak. And in this case, I'm thinking about some of the drone customers that we have. we've been able to, in many cases, give them up to 15x more throughput. And at the same time, instead of using 5 boards, they're using 1. And so that reduced the cost, it reduced the physical footprint, but it also reduced the power consumption, which means that drone goes longer periods of time out there. So again, you're
Oh,
changing the profile, what's possible by moving these 3 variables around. Now you can rethink, where does that edge compute happen and how does it happen?
I think that's so interesting. Well, this is so cool because it's like maybe the battery technology, because uh, like generative AI consumes so much power that
Yes.
like maybe you're bringing the equivalent of like the size of a Tesla lithium battery on site, and that might be pretty inconvenient if it's like rough terrain. And it's cool. The technology will get better eventually, but it sounds for specific use cases you can get like the power storage small enough to do some pretty remote things. I'm
Right.
just hearing the depth of the form field, like the
Yes.
form input, because if you could
Yes.
get, yeah,
Yes. You can. I mean, that was with our SEMA customer. And then even just with my previous role, the whole idea of using drones for collecting images, right? Now, instead of collecting images and sending it to the cloud and doing analytics days later, right? What if you can collect the images and you have your models trained already and you can do real-time predictions? And that means you can do real-time decisions. What do I do now in the next few minutes or hour? Again, only that you as the expert knows the value of changing your actions between knowing and action from days to minutes. If there's some value there, Caden, that's worth looking into.
well, especially since the cost of not making a decision like multiple days. I mean,
Yes.
something I'm doing. I mean, like if it takes like 24 hours and like to miss, like for like in a financial scenario where you're sending money, like you're a fintech, and the cost of getting like 100 transaction points of data takes about a business day. Okay, you missed the banking funding window. If it's on a Friday, yeah, wait all weekend to get that money.
Right.
If you could close that gap, just getting the data to the decision making engine, the governor, to use your words, like then like you just think of like the unlocked GMV of,
Mm.
of like a part of an economy where there's like the lower delays, like they're more like unlocked value.
That's right. That's right. And like we were talking about in the manufacturing sector a few minutes ago, right? For them, it's at some point you have to get good throughput, good yield. But after they solve that, then it's making the team more productive. You got that. The other thing that becomes proactive. The moment you can connect one sensor to the upstream sensors and you can start doing some analytics in minutes, you can start taking preventative actions before something really bad happens. And let me give you an example. Like this is a long time ago, but it's still true today. So when they're building like in a tissue machine, like they build parent rolls become our tissue paper in our bathrooms. When they're trying to avoid something called a web break, what they're looking for is, hey, do I see repeating defects at the end of the line? You got like 4 to 8 cameras at the end of the line looking down at these speeds, trying to detect something that's repeating. Once they see the repeating factor, they then talk to the cameras upstream in real time. And then you apply the business rules. If this is repeating this often, then you start taking actions, right? This goes back to your point, edge compute in real time. What they're able to do once they see that pattern is happening and they know where it's getting introduced, i.e. upstream in the process, what they're now moving is people to go fix that ahead of time. Because if they don't, that thing is a web break. It's $30,000 lost every time it happens. 30,000 gone. You just lost it. Because now you have downtime and you lost, not only the line's not running, the product is lost. And then you got to you have labor to put the line back into operating order. That again is just an example of where condensing this information instead of sending it to the cloud and a couple days later looking to see if there's any patterns, you have systems in place that are making those decisions in real time.
It's almost too expensive to like have an analyst do it and like in a delayed manner. I mean, in the produce industry, like a lot of like big operational expenses are like burst capacity, temporary labor, like harvest or, pruning vines to increase yields. And so if a rain like El Nino comes in and the rains come early, like you're not going to be able to deploy 2,000 workers fast enough in a remote location. And so one of our customers, that happened, the rains came early, the vines overgrew, and they weren't able to meet their commitments.
Oh.
And because it's like, you can't just like deploy thousands of people. Like you're kind of this fingers crossed gambling that like, okay, like hopefully based off last year's weather, maybe like this is when we'll start hiring people, because if too early, then it messes with the economics of the deal. And I think this is why like produce as like a global industry is just a very tough problem to solve, because you can't be making those decisions fast enough. And so there's really like in industries like that, like the current status quo is insurance products and, handshake agreements to amortize losses, because it's like, we can't make decisions fast enough, too many variables.
Yeah.
But it's looking like we're getting close to the technology to solve that.
Well, definitely, at least we start rethinking what information, if that faster, back to that spectrum, right? What would we do differently? And that goes back to one of my two governors, right? It's a perfect prediction of this X, Y, and Z. What would you do with that? Right? And I have to commend you. There's a lot in what you talk about the produce, because also with the climate situation we're seeing far more volatility, and with volatility also more intensity of that volatility. It's going to have to change the types of information we need to make decisions, even today's decisions, better.
And how fast, right? Elizabeth, do you feel like there is anything that hasn't been said that should be said before we sign off? And how could people find your work and connect with you? And
yes, absolutely.
Yeah.
Absolutely. Well, Kaden, it's been a real pleasure. I think we touched upon some important points around maturity, the importance of making sure that we help customers find the business value and deliver the business value at scale. But I think one of the things that we also have to know is be okay, be comfortable with where we have to start. Everyone has a starting point. It's not the same, but we all do. And I leave you with, and your readers and listeners, look for your pockets of possibilities. They're there. And choose one or two. And where you ask yourself the kind of questions we just talked about, where would a faster decision make a difference? Is that addressing my governor today? And then once you do that, I encourage you to reach out to SEMA at SEMA.ai. And you can find us on LinkedIn or on our website. And truth be told, I'll also be at AWS, or if any listeners are going to be at AWS this year, let them please, I welcome you to ping me. I would love to meet you in person.
And then SEMA is spelled SIMA.ai, SEMA.ai. So yeah, well, very, very interesting and practical episode on taking it to the next level of AI. Elizabeth, thank you so much. You have a good one.
Thank you so much, Kaden. Take care.
Hey listener, thanks again for listening to The Way of Product. As we power down today's session on the fusion of creativity and technology, let's solidify the energy you've gotten from our dialogue today. If you've gleaned insights or strategies that could turbocharge your projects, I have a small but powerful ask. Swing by the platform where you're hearing this and leave a review. Think of it as your digital high five to us. It's a fuel that propels this content to more creative technologists like you, amplifying the impact of the shared knowledge. So until our next interview, keep pioneering and pushing the envelope. Thanks again for lending your ears and your imagination to our community. Catch you on the next download.